3.6 Transformation of graphs of a linear function. Recall that a linear function is a function whose graph is a line. Here in this lesson, we're going to be learning translation and reflection. So remember, translation is another word for slide, and reflection is another word for flip. The most basic functions in a family of functions is going to be called the parent function. In this case, our parent function is going to be f of x equals x, which f of x is the same word. It's going to represent y. So this in a way is y equals x. This is very important to remember that this f of x is y. So a transformation changes the size, shape, position, or orientation of a graph. Okay, here we have the core concept of the translation, which is basically a transformation that shifts the graph horizontally or vertically. So horizontally happens which way? Left, right, correct. And vertically happens up and down, correct? So here we have, when it's a horizontal translation, the graph y equals f of the quantity x minus h, correct? So in a way, think of h as being what? Horizontal, correct, as a horizontal. So is a horizontal translation of the graph of y equals f of quantity of x, correct? Where h cannot be what? 0. If h equals 0, which is horizontally, what does that mean? We're not having a line, correct? It's not going left to right. When we subtract h from the input before evaluating the function, the shifts of the graph go from left when h is less than 0 and right when h is greater than 0. Okay, now opposite, what are we doing now? So kind of in a way, you see this little arrow right here, they're going which way? To the left, because h is less than 0. When they're going to the right, h is who? Greater than 0. Vertically, if we see here, we have what? Up, and we also have down. Vertically, when y equals f of x plus k. So what's happening with k here, with our x and k? We're adding k to the outputs. Okay, we're adding k to our outputs. So if we have, remember our outputs. Outputs are what? Our y's, correct? Outputs are our y's, our inputs are x, domain and range. It's all relatives. So when our k is less than 0, we're going to go, let me write that a little bit neater. We're going to go down. When k is greater than 0, we're going to go up. Okay, let's do some examples. Here, horizontal translation and vertical what? Translation. Let f of x equals 2x minus 1. Graph A, g of x equals f of x plus 3. And B, t of x equals f of the quantity x plus 3. So in a way, we recall on a previous graph, this is, on a previous slide, not a graph, I'm sorry. Here, this is who? That's our parent. That's what we're going to compare it to, okay? So, can you graph this? Do I have a pen? Yes. Can we graph this? F of x equals 2x minus 1. We're going to use that for A and B. This is our A graph and our B graph. So I like to always start with graphing it so that I could see what's happening with my transformation, okay? It's the best until we fully understand it. So we know that f of x equals 2x minus 1. That's the same as saying what? The slope-intercept form, which is y equals 2x minus 1. When negative 1 is who? Our y-intercept, correct, our y-intercept. And 2 is our slope. So I'm going to find where our lines will be intersecting. In this case, it's in negative 1. I use red over here. Negative 1 is around here. Then our slope is positive, so that means I already know my line is going to be negative, or is it going to be positive? It's going to be positive, correct, because our slope is positive. Even though our y-intercept is negative, does not mean that our line is negative. Just the slope determines it. So we're going up 2 and over 1, correct? Because it's going to be 2 over 1 for our slope. Move up 1, 2, over 1, 1, 2, over 1. And even vice versa, we could go 1, 2, downward, right? The more points we have, the more precise line we can achieve. Let's see if I can make this straight. Oops, that is not happening. Okay. Okay, very close. In Notability, you're able to do what? Yes, hold on to the pen down and it will give you a straight line. So that is going to be apparent. I'm going to do it to both what? To both examples it's telling us to look for. So here we have, again, negative. Use the same color so that I can see it. 2 up, 1 over, 2 up, 1 over. All right, so now we're ready to do what? We are ready to explain or describe that transformation of A and B, the new lines. Here we have what? G of x, all right, equals f of x plus 3. Why that kind of reminds us from the core concept that we had before. We had what? K's, that kind of the same as what? Y equals f of x plus k. Right? It's in the same format. What's happening? We're adding k to our outputs. Here, they're telling us to do what? K equals who? K equals 3. So therefore, from the graph of G, it's going to be a what? I already know that this is outside, so it's going to be the K we're adding So we're going to have a vertical translation. And it's what? It's k less than 0 or is k greater than 0? K is what? Greater. So that means we're going to go 3. Remember, we're getting it from k. 3 is greater than 0. 3 units up of the graph of who? FF. So we're doing it which way? Which way are we? Correct. We're going up. Up. You could any points. That's why sometimes when you have the more points you have, your line becomes more precise. So we're just going to, I'm going to go up 3. 1, 2, 3. From this one, we're going to go 1, 2, 3. 1, 2, 3. That looks very lopsided. Okay. There we go. So we know that, which one was our parent? We know that this one was which one? F of x equals 2x minus 1. We were given that. The second one was our A, I'm sorry, not the second one. It is g of x equals f of x plus 3. And that's your answers, okay? There's a vertical translation. 3 units up. B, they gave us what? T of x equals f of the quantity x plus 3. This is the same as which one? Remember back to our core concept. Which was what? Y equals f of the quantity of x minus h. Correct. So I see that h already. And I see who's h here? H is who? Yes, h is my negative 3. And I know you're thinking, okay, but in the questions, it tells us right here that it's positive, correct? Right here that it's positive. But we are what? Comparing it to whom? Exactly. We're comparing it to f of x equals 2x minus 1. Where they're telling us that it is minus and over here is minus 2. So when we have negative 3, the graph is going to be, the new graph is going to be what? Horizontal. We know it's horizontal. A horizontal translation. A horizontal translation. 3 units where? What do we say? If h is less than 0, it's to the left. Is h here less than 0? Correct. So we're going to go to the left of the graph of f. So our new line is we're going this way. 3 units. 1, 2, 3. 1, 2, 3. 2, 3. So that will be given as T of x equals f of the quantity x plus 3. And our parent, again, what was f of x equals 2x minus 1. So the transformation that's happening here is horizontal translation to the 3 units left. Now we have the core concept of a reflection is a transformation that flips. Again, the word flips a graph over a line, that line of reflection. So the graph, the reflection in the y-axis happens when y equals negative f of x. Okay? Is a reflection over the y-axis, which our parent was originally what? Y equals f of x. Which way does a reflection happen on the x-axis? We're basically multiplying the outputs. All our outputs. Outputs are what? Y by negative 1 changes are signed. We're going which way? When it is a transformation, where reflects on a transformation, a reflection over the x-axis. Are we going? Yes. Think about it like you're crossing over. So this is here this here's a parent, right? Y equals f of x. That's what was given to us. So now the line, which way do we go? Do we jump this way or do we go this way? Correct. So we went this way. And what are we seeing there through? The what? Correct. That's the x-axis right there. When we're reflection in the y-axis, you're doing what? You're multiplying inputs. And who our inputs are? Our x. By negative 1 and changes their signs. Here we have the graph being, when graphing y equals f of negative x. Correct. So this is all related to here and here. It's transformation. And which way we're going? This way. Correct. We're jumping over y. Reflections in the x-axis and the y-axis. We're given again a and b. We're going to let f of x equals half x plus 1. Can we graph this? Yes. Where our slope is half and our y-intercept is 1. One over here, 1 up and 2 over, 1 up and that is going to be woo? F of x equals half. I am going to just right here so you guys can see the little hole. This is going to be F. We're going to work now in A, which A is who? A is g of x equals negative f of x. The best way to do this is to find outputs. We're going to find outputs because based on our core concept, we established what? Who we were multiplying here. We're multiplying all our who. What are we multiplying? Our outputs by -1. We are what? Multiplying the outputs. So in a way, we are looking for x with negative f of x. Okay, because we are what? Multiplying our outputs. We will construct a table, so you pick what? You're able to pick. Always pick low numbers because the highest number that you have, the outer and bigger you need to do your graph outside of the grids. So I'm going to personally pick which numbers. To make the table, I will pick -2, 0, and 2. This is going to be which one? My x. Let me write this here. X, which is going to give me -2, 0, and 2. Who did we establish our outputs, which is f of x, correct? Is who? Just plugging in our inputs to our outputs. So here we have what? -2 times what? -2 times what? Our parent, correct? Our parent original function, which is -2 times half plus 1, correct? So we have half times -2 plus 1. Half of -2 is -1. And plus 1 gives me 0. Then we have what? Half times 0 plus 1, which gives me 1. And then we also have 2 times half, which gives me 1 plus 1 gives me 2. That's in an original one, but now they're telling us to multiply times what? Multiply by -1. So we're going to have what by -1 now? This is negative f of x. 0 multiplied by -1 is what? 0. 1 divided by 1 multiplied by -1 is -1. And 2 multiplied by -1 gives me -2, correct. So that's our new points. For who? For G, correct, for line G. So we have what? -2, 0, -2. Kind of see the line already there. 0, yes. We're multiplying. We're plugging in these order pairs with these. Which that gives us what? -2, 0, 0, -1, and 2, -2. Remember that x is our inputs and the f of x is the same as y, which is our outputs. So we have -2, 0, 0, -1. So it's 0, -1. And 2, -2. So whose line is this? Correct. That is our G. So we've done that. What's happening there? It's a reflection. It's going which way? Correct. We're going this way. So it's a reflection over who? The x-axis. Of the graph of f. Now we're going to do B. B is t of x equals f times -x. So who do we multiply now by -1? The inputs, correct, the input. So we're going to have another table, yes. So we're going to have x. We're going to have x I'm going to use the same points. -2, 0, and 2. Who are we multiplying now by -1? Our outputs. This table came out fatter. It's okay. So, what's -2 times -1? +2. -1 times 0 gives me still 0. And -1 times 2 gives me -2. Now we have f of x times -x. We'll be using our parent equation, which was what? Half of x plus 1. Here, who's x now? 2, correct? Because it's the -1 that we are using now. So half of 2 is 1. 1 plus 1 gives me 2. If we input 0, half of 0 is 0 plus 1, which gives me still 1. Then we finally have -2. Half of -2 is -1. And -1 plus 1 gives me 0. You're going to use which order pairs? These with which ones? With the one we just solved for. So, let's plug in -2 and 2. -2 and 2. 0 and 0 and 1. And finally, 2 and 0. What line is this? T. What happened to reflection? Reflection, right? Reflection over the y-axis. So we were originally where? F, correct. And now we moved which way? Kind of the line is touching, yeah. You kind of, yeah, correct. You see it. It's right there on the X. Stretches and strengths. You can transform a function by multiplying all the x coordinates, which are inputs, by this factor of a. Okay, do we know what a represents? No, but it represents a number. When a, that number that you multiply your inputs by that a, if a is going to be greater, then the transformation to happen is going to be a horizontal shrink, because the graph shrinks towards the y-axis. When 0 is less than a and less than 1, the transformation is going to be horizontal stretch, because the graph stretches away from the y-axis. In each case, the y-intercept stays the same. Okay, the y-intercept stays the same. You can also transform a function by multiplying all the y coordinates, which are who? Our outputs, by the same factor of a. So now we're multiplying the y with a. Before we're multiplying our inputs by the factor of a. When a is greater than 1, it's going to be a vertical stretch, because the graph stretches away from the x-axis. When 0 is less than a and less than 1, the transformation is going to be a vertical shrink, because the graph shrinks towards the x-axis. In each case, the x-intercept stays the same. It's kind of the opposite, right? One is going to be what type? An horizontal, and the other one will be vertical. So you have horizontal, shrinks, and stretch. The shrink happens when a is greater than 0. The stretch happens when 0 is less than a, less than 1. We also have a vertical, which is going to be a shrink and a stretch as well. And a shrink happens when in a vertical, when 0 less than a, less than 1. And the stretch will happen when a is greater than 0. So it's kind of, if you look at it, it's going the opposite way of what the horizontal and the vertical. The core concept is horizontal stretches and shrinks. So the graph of y equals f with what? Yes, when we multiply a times x. Okay, a is x. That a, when a is bigger or greater than 1, what is happening? When a is greater than 1, what is happening? We just did that. When a is greater than 1, we having a, yes, a shrink. But when 0 is less than a and less than 1, still multiplying, but we have a what? A stretch. We have a what? Correct. We're having a stretch. So you know, we kind of could see it. If the best way I can tell you guys to explain it to you guys is, if you see a number next to your x that needs to be multiplying, not added, not subtracted, but multiplying, that automatically should give you a giveaway that it's going to be a horizontal. We just need to figure out if it's going to be. That's the first step My pen is breaking, I'm sorry guys. That's the first step that we should look at. What's happening? When it's a vertical, okay? When it's vertical, you're doing what? Y equals A times the f of x. You're multiplying the whole function, f of x, to a. And if a is greater than 1, what's going to happen if a is greater than 1? You're going to have a stretch. But if it's 0 less than a and less than 1, we're going to have a shrink. So if you notice here, this is where I think if everybody gets confused. First, determine if it's a horizontal, vertical, and stretch. So step 1 is determine if it's horizontal or vertical. Steps 2, what are we going to look for? The graphs. If it's y equals f of a times x and y equals a times f of x. That's the first 2 steps I want you guys to determine. From there, then you determine if it's going to be a stretch or a shrink. So, in step 3, we're going to, if it's going to be greater than or less than. And finally, because the greater than or less than determine if it's a what? Shrink or stretch. And in step 4 is graphing. Sometimes we have to do what? Work out the equation with points, or we give our points, which are inputs. We could have a translation with a shrink and a stretch. Correct. And a reflection as well. We will practice it now. Horizontal and vertical stretches. We know that a parent is they're telling us that it's let f of x equals x minus 1. That will be your parent. Can we graph that? Yes. Which m is our slope. In this case, it's 1. Remember, there's an imaginary 1 in front of our variable, which is an x, in front of variable x. And our y-intercept is -1. Let me draw my lines. I'm at -1. And our slope is what? Yes, 1 up and 1 over. 1 up and 1 over. What line is this? Yes, that's our F. Now we're going to find our lines G and H. And A, they're telling us that G of X equals F times 1/3 X. What kind of way can I see it's going to be what? What we're going to do here, we're going to find outputs of G. So we're going to multiply by what? By 1/3. To finally evaluate with F. let's look what we have. So here it's going to be basically x f of x 1/3 x. Remember that we established that anytime you see f of x with a g of x, h of x, I of x, g of x, that's the same as who? Of y, which is our output. So here what I'm going to do is to find different points, I'm going to do a table, construct a table. You could pick again any numbers. I like to do low numbers so I don't have to sit here and do what? Work out so much. Computation. Picking out numbers, I already know I'm multiplying by a fraction. So what is my denominator on that fraction? 3. To make my life easier and do what? Multiplicate. And yes, I'm going to use 3. Because if not, what's going to happen? Yes, I'm going to be stuck with more fractions. And we know we love fractions. So I'm going to have x, -3, 0, and 3. We are multiplying 1/3 times x. It's from over here. That's why they told us to multiply. What's 1/3? Remember that 1/3 is the same as our a, correct? 1/3 is our a from our stretches and strings. So -1/3 times -3. 1 times -3 gives me, correct? -3. -3 divided by 3 gives me -1. Now we have 0. And 0 divided by 3 gives us still 0 came out lopsided. And then finally we have +3. And 1 times 3 gives me 3. And 3 divided by 3 gives me 1. Correct. So I'm done with that part. Is that my complete one? No, because they're telling me that it's finally going to be what? F of x 1/3 x. So what am I going to multiply now with? I have to do what? Use my family, correct? And who was my family? Yes. This is the origin. I'm comparing it. You're basically comparing. Remember, these are going to be my lines for my order pairs, which are my points for the line of the new, which is G. But what I'm doing is comparing between what's happening from G to F or F to G. No, from F to G, correct? Because we were given a parent and we are seeing what our line is being the transformation. So now we're going to have f of x equals x minus 1. We already computed and transferred by substitution what? Our x, our original inputs. Now we have been given new inputs, which are what? When f of x equals -1, which this is our x, we have what? -1 equals, minus 1, which gives us -2. So we have -2. This is the same as what? Remember y equals x? Because f of x is the same as y. Now we have 0. Oops, let me erase that. And 0 minus 1 gives me -1. And then we have 1, correct? Remember, we're doing it based on which ones? So, erase that 0. It's not erasing. Okay, I'll just rewrite it. F of 1 equals 1 minus 1, which gives me a 0. So our new points are going to be what? -3, because remember, originally it's going to be x with the f function of f1 of multiply 1/3 times x, correct? 1/3 x. So here we have -3, -2, 0, -1, and finally 3 and 0. If I was to plug in these numbers, we have what? -3, 1, 2, 3, -2, 0, -1, we're meeting here, and finally 3, 0. So our line for G is going to be over here. So who did we touch? What did we do here? We had a horizontal what? Is A, that's 1/3, right? A represents 1/3. Is that less than? Yes. So we had a what? A stretch. And what's happening? It's stretching away from who? From the y-axis. So we have a horizontal stretch. It is, and it's less. It's a horizontal stretch. It is moving away from the y-axis. Have you noticed? Where's the y-axis? Correct. It's moving. It is moving away. Moving away. By a factor of what? Why is it by a factor of who? Less 1, right? If it's less than 1, it's going to be a stretch. So it's going to be 1 divided by 1/3, which was our A. And what is 1/3 divided? 1 divided by 1/3 gives us 3. Now we're moving on to B, which in B is our who? H line. So we have h of x equals 3f multiplied by x. We are going to look for x, which is 3 of x, correct? Who's A here? Who can tell me what A is? Who's A? A is R3. Okay. We're going to construct another table. We have x. What do we have? F of x. This is original. F of x. And then finally, 3 of x. What numbers am I going to use? You could use the same numbers or different ones. Remember, when in fractions, you want to use similar denominators, numbers, so that way, well, divisible. So it'll be easier for you to work them out. This is already 3. If I use big numbers, I'm going to be multiplying bigger. So I'm going to have -1, 0, and 3. So let's work this out. We have -1 what? What are we multiplying? Our parent, which was our parent, which what? F of x. It's right here. That's our parent. F of x equals x minus 1. if I have negative 1, no, did I do negative 1? I have negative 1 minus 1, substitution, like negative 2. Then finally, if I have 0 minus 1 gives me negative 1. And then finally, if I have, I should have used 2. I'm going to use, or even 1. I don't know why I used 3 over here. I think it's because of the factor of 8. So I'm going to use 1. And then finally, 1 minus 1 gives me 0. So we figure out f of x. And then finally, we're going to have 3 times f of x. So we're going to do now with a factor of who? S of a. So here we're multiplying our a, which is our a is who? 3. What are we multiplying times 3? So remember, we have, I know it's a little bit confusing. We have the f of x, multiply whatever that is times 3. Correct? So what do we have here? Negative 2 times 3 gives us negative 6. Where's the pencil? Negative 6. And then 3 times negative 1 gives us and then 0 times what? 3 gives us 0. So our new ordered numbers are going to be negative 1, negative 6, 0, negative 3, and finally 1 and 0. Graphing out with negative 1, negative 6, 1, 2, 3, 4, 5, 6, 0, negative 3, 1, 2, 3, and then finally 1 and 0. So that's going to be for a line H. So what happened here? Graph of H is going to be a vertical stretch because A is 3. And we already know we were multiplying what? What we were multiplying? Yes, we were multiplying our output by the same factor, which was who? A factor of A. But A in this case was what? What was happening to A? A was greater than or 1, so that's why it's a stretch. By a factor of what? It's going to be a stretch by a factor of? By a factor of 3 as well. Horizontal and vertical strengths. We have here the parents as f of x equals x plus 2. We know that we could graph this because our slope is 1 and our y-intercept is 2. Remember to graph right away the parents. It kind of helps you. We know that its y-intercept is 2 and our slope is 1. So this is our line F. Now for A, for line number A, they're telling us the line G of x equals F times 4x. And what we're going to do here, we're looking for x is function of F for x. Then we're going to create a table. Okay. This is 4, so I'm going to use -1, 0, and 1. What are we doing? We're looking for first the inside, which is gonna, who are we looking for? Inside, which is 4x. To then finally, ultimately look for f of 4, the order pair of these, right, with x. We plug in, we're going to have what? What are we plugging this into? 4 times from here. 4 times -1 gives me -4. 4 times 0 gives me 0. And 4 times 1 gives me 4. And then finally, we're using it with the parent, which was what? X plus 2. What is our new one now? -4 plus 2. This is our new, which gives us -2. Then we have 0 plus 2, which gives us 2, and 4 plus 2, which gives us 6. We finally have our order pairs, where they're going to be -1, -2, 0 and 2, and 1 and 6. Am I able to graph already? Yes. For line G. 1 and -2. Zero and, I did this wrong. -1 and -2. 0 and 2. And 1 and 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So our line is going to here, which line is this? G. What do we have here? Horizontal shrink of the graph of f by factor of 1/4. In B, we have line h of x equals 1/4 f. We're looking here for x 1/4 x. Correct? So, again, we're going to do our table. I have a fraction. Because I have a fraction, I'm going to do it. Use multiples that are going to be divisibles, right? So, I'm personally going to do -2, 0. I could use also -4, 0, and 4. What are we solving for? Right here, f of x, which is what? When I plug in -2, so now we have -2. Remember, f of x is the parent, so it's -2 plus 2 gives us 0. 0 plus 2 gives me 2, and 2 plus 2 gives me 4. And finally, we're going to actually apply with the whole new transformation. So it's going to be 1/4 what? Times 0, which gives me 0. And 1/4 times 2, 1/4, I put half. 1/4 times 2 gives me 2/4, correct? Which gives me 1/4, not 1/4, half. And then finally we have 4 times 4, which is the same as 4/1, which gives me a total of 1, right? Because 4 times 4 gives me 4, and 4 times 1 gives me 4, which is 4/4 gives me 1. We have our order pairs now, which are, what's going to be an order pair? -2, remember, we're looking -2, 0, 0/2, and 2 and 1. This is -2 and 1, 0, and what? 0.5, and 2 and 1. And this is for line 8. We have a what? Vertical. Because 1/4 is what? What is 1/4? One-fourth is less, right? So it's going to be a vertical shrink. Vertical shrink by a factor of 1/4.